Hi, welcome to Dissolve Chemistry. In the previous video of thermodynamics, we have discussed regarding first law of thermodynamics and we formulated the mathematical form of a first law of thermodynamics. See, in that we have discussed there is no perpetual machine can be built that which can do work without expense of the energy. Okay, and similarly we defined it as the internal energy of isolated system remains constant, it is not going to change. So that also we have discussed in the previous video. In this video we will discuss a very important aspect, that is expansion work. Okay, we are really fond of this expansion work. Usually we say that 1 mole of gas is packed in the cylinder and it does work. We used to write P into V, pressure into volume, like that we are going to P delta V. So like that we are going to mention how it comes and what it means. So all that we will dissolve in this particular video. So first you consider, say for example, a system is there. In that system what we have done is, okay, so on that system the state of the system is infinitesimally varied, means small change has been brought in that system. Okay, state of the system, say temperature, small change dt, small change in temperature we have done. As you change infinitesimally temperature, then what happens? Internal energy will also change by infinitesimally, means du, okay, by du quantity your internal energy is going to change. Now suppose you are doing infinitesimal small work on the system, small work on the system by dW. Okay, similarly in the meantime what happens, it is going to absorb small amount of energy in the form of heat, infinitesimal small energy in the form of heat, then we call it as dQ. Now from these we can formulate our first law of thermodynamics as du is equal to dq plus dw. Okay, now really if you want to use this equation, this expression, okay, right, we must know that what changes are happening in the surrounding during these changes are happening in the system. When these changes are happening within the system, then what changes really happening in the surrounding, if we know, if we relate that, then we can make utilization of this equation properly. Okay, so to do so that, let us consider the expansion work means what. Okay, if we understand that, then we can relate that with this particular equation and we will be in position to use this one. Fine. So prior to going for this expansion work, first you should know what do you mean by this expansion work. The expansion work means the work which is going to bring the change in the volume. Work which is appearing in the form of change in volume is called as expansion work. Fine. To understand that, let us consider a reaction. Calcium carbonate, solid. When you heat at high temperature, then it will decompose to give calcium oxide plus carbon dioxide gas. Okay, so now if you carry out this reaction in an open vessel, then you cannot observe any changes in that, right? Now what you do, this reaction mixture means that calcium carbonate you take in a cylinder, say for example, which is fitted with a piston, right? It is fitted with a piston and you have taken calcium carbonate here. Okay, now what you have done, you are heating this one. So now as you go on heating this, then what happens, it will decompose and as shown in the reaction, and carbon dioxide gas is generated. So 1 mole of carbon dioxide is generated when 1 mole of calcium carbonate is burnt. Then what happens? So immediately what happens, you will observe that there will be a what lifting of the piston will take place. Piston will move up, okay, in the upward direction, meaning we call it as what? Expansion. Gas will expand, okay. As this gas which is being released, initially the volume was very small, confined with a small volume. Now what has happened? Now the volume has changed, okay. Due to what? Due to formation of the carbon dioxide gas. And that carbon dioxide gas will now what it will do? It will expand. So during that expansion, what is happening? You should observe that one. So during that, what happens? Say for example, this is your initial volume, right? So as gas is produced, slowly what happens? Your piston will move up, and as almost all of the reaction is complete, now complete gas is being formed, then the piston will move to certain level and it will stop there, and that we call it as V final volume, okay. And this change in volume what has happened, so for that your gas what it is doing? It is doing work, and that work we call it as what? Expansion work. The work during which there will be a change in the volume, if it happens, so then that work is called as expansion work, okay. So prior to going for its form, so we will see that what is the definition of this work. In physics, we define this work as, okay, so displacement of an object. Here object is your piston, okay, you should compare like that. Your object is here piston. Displacement of the piston or an object, okay, against an external force, okay. So say for example your piston is moving in the Z direction, right? So then the displacement in the Z direction, okay, how it happens? Against the external force F, and we are showing by minus sign, means as it is an opposing force. Force is how it is? Opposing force. Opposing force here it is. In this case your opposing force will be what? External pressure. Are you getting my point? Force is here external pressure. We'll go in detail with that. So now to understand this work, okay, so let us consider. So the gas formed, or you take a gas is confined in a cylinder which is fitted with a weightless frictionless piston, right? Gas is there inside this system. Then what happens? Okay, and the area of this piston is of area, you can take A, right? And the external force we call it as what? P external. There will be a pressure external which is constant. Atmospheric pressure will be there. Now what happens? Gas expands. So the external pressure, your gas is expanding, okay, or it will move, right, by dz distance, right, against what? P external, okay. So then how we will give the force? Force is in what form? P external into its area. So how much area of the piston you have, that all is being lifted by your gas by a distance of dz. So therefore force is equal to what we call as P external into area as opposing force. External pressure and on how much area it is acting. So that product we call it as what? Opposing force. Okay. So then if you substitute, so now F is what? P external into area. Because why we have taken this product of pressure, external pressure into area? Because the piston is having certain area, and over all the area P external is constantly acting on that. So therefore overall opposing force will be equal to what? P external into area. So as it is rising up, so then we will write dW is equal to minus P external into area into dz. And you should remember that area into distance, that is dz, which is being covered by the gas during expansion. So that we call it as, or we represent that by dW is equal to minus P external into area. You can take it as L square, length into breadth L square, and this is also L. So becomes L cube, that is nothing but volume. So it has been changed. So therefore we will write dV. Is it clear? So the small change in work or small work done by the system is equal to minus P external into small change in the volume. Now if the gas expands from its initial volume Vi to V final, so then we can get the work as the total work done will be equal to minus integration of V between the limits V initial and V final. So therefore minus P external into dV, we will write like this. Okay, so then what happens? So W is equal to minus P external into delta V, we are going to write. So this is what we call it as expression for the expansion work. Now if the same thing, if force is acting externally, if the force is internal one, okay, so you are doing work against the internal force, then we call it as compression work, and that is also of the equal magnitude it will be. Okay, it is also against the opposing force we are doing work, and this work we call it as what? Expansion work. Okay, usually we use this equation in our thermodynamic discussion, and probably students used to be in confusion that how it will come and all that. So that all we have discussed here. There is only one form of work? No, there are many other forms of work also we are going to see apart from this expansion work. So the change in volume, work done during change in volume is nothing but expansion work. And other forms of the works will be generally like electrical work will be there, okay, extension work will be there, surface extension work will be there, okay, many other forms of the work which we call it as what? Useful work, or it is also referred as what? Non-expansion work. Okay, so this is expansion work. Other than this, rest other forms of the works are all called as non-expansion works, or also referred as what? Useful works. I hope you have understood what do you mean by expansion work. In the next video, we will discuss regarding expansion at constant pressure, isothermal expansion, reversible and irreversible conditions. Thank you for watching.